everybody. This is Becca with Empowering Pumps and Equipment. I'm very excited because I have Jim Anderson here with us from Coupling Corporation of America. And Jim, why don't you tell us a little bit about yourself?
Yeah, Jim Anderson. I am Vice President here at Coupling Corporation. I've been here for a little over 20 years. So I'm starting to learn the ropes.
Well, I'm excited to have you here and I'm excited to learn from you. So Jim, why don't you, take us through your vertical products for pump applications?
Perfect. So yeah, we're going to talk about our vertical products. Many people know us more for our flexible couplings, which mainly are on horizontal equipment, pumps, compressors, turbines, motors, all those kind of normal equipment. But we also have a very unique product line that fits with vertical equipment. So I'll talk a little bit about some of those products, how they work, some of the advantages they might have for different kinds of users. So just a little background on us. We've been around for over 55 years now. So we've always focused on high performance equipment, whether that's compressors, pumps, turbines. We like things that spin fast and have a lot of power. That's where we do our best work. And this product that we're talking about today really comes from our Anderson clamp pump, which has been around for probably about 30 years now. And a lot of people love it because it's a mechanical shrink fit device that grips onto the shaft using friction. So this is a quick example, just a little diagram, and you can see it has there's a hub with a flange, and then there's a collar that screws onto it, and then a set of loading screws. And the loading screws, as you tighten those loading screws, it pushes the collar. In this case, it pushes it to the right. And you can see here's a little different cutaway. As you push it more and more, those tapers engage with each other, and now you create interference as they try to move up the ramps. And what happens is then the inside piece, in this case the red piece, would squeeze down on the shaft. So we've used this for many, many years on all kinds of different applications in rotating equipment. And a lot of people have fallen in love with it, and they've asked us, why can't I use this on my vertical equipment? And we said, that's a great question. You can. So over the years, we've developed some products that really work well on vertical equipment. And typically, this is a little cutaway, but typical maybe a turbine pump. And you can see we've got products that will work between the motor and the pump. That's a vertical clamp coupling. We've got a product that works on line shafts. So if you have a deep well or some kind of long section type pump with stages of shafting, that would be the appropriate product there. And then we also still make flexible couplings that in some cases will be used on a vertical application, depending where the bearings are in the application. So today we'll talk mainly about the two rigid options, just how they work, how they fit in. So this is the line clamp coupling, and as I mentioned, this all comes from our Anderson clamp hub technology, same type of technology, but it's been modified to use in this application. So what's really neat about it is it's designed to work on smooth shafts. So right now, a lot of people use threaded shafts. They'll have a shaft and it's got a thread on one end, thread on the other end, and then they get threaded together with a threaded coupling. And this allows you to get away with those threads. Just use a straight, smooth shaft, and the hub clamps onto both the top shaft and the bottom shaft. And this makes it a lot better for a couple different reasons, but it does make it a lot easier to make modifications in the field. It also works in both directions, which is great because a lot of times threaded couplings, if you happen to spin the motor the wrong way in testing, you'll break everything apart. You'll push it apart and end up breaking something in the system. So this is a little cutaway of it. You can see we're loading the hub from one end, and sometimes we load it from both ends depending on the torque requirements. But what happens is you squeeze the top shaft and the bottom shaft at the same time, and now you've got a nice rigid coupling. And this is designed to work usually this would be in the water flow of the pump. So it's got to be a low diameter. And the nice thing is when you look at a lot of applications where you submerge this pump shaft and you come back 2 years later, 4 years later, and try to get it apart, many people will tell you, boy, it's impossible to get my threaded stainless steel couplings apart. This helps to eliminate that problem by clamping onto the shafts. You're not getting all of the galling and the corrosion that would happen inside a thread. So it releases much easier, and hopefully you can then save your shafts, use them again, not have to worry about replacing shafts all the time. And as I mentioned, it does it bidirectionally. So if you do happen to hook up the motor the wrong way, you're not just pushing the two ends apart and blowing out something at the top or the bottom of your system. Here's an example. This is in actually a nuclear power plant. This is about as big as you can get in a pump. You can see this is over 5,000 horsepower pump running at 350 RPM. And those shafts are a little over 9 inches. So it's a pretty big pump, and the thrust is enormous. It's 200,000 pounds. So that coupling is not only carrying the torque load, but it's also responsible for carrying that thrust. So as the pump is at full power, it has to be holding that impeller from pushing off. So this is it's a neat product. This is all stainless in this case because it's underwater, submerged for years. In this case, we have a double-ended action. So we have loading screws at each end, and that just helped to provide a very large safety factor in this case, just to make sure there are no problems. Now I'll show a little bit more about our vertical clamp coupling. So this would be, you remember from the beginning, this would be at the very top of that stack, so between the motor and the pump. So normally this would be in a dry spot above the working part of the pump. And this is it's a rigid coupling, so there's nothing flexing in the coupling, and it's designed to carry torque, and it's also designed to carry the thrust pump would generate, or even just the weight of the pump rotor itself. So we've got a couple things to note about it. There are no keyways needed anywhere. There are no slots. There are no threads. And all the components are all piloted together. So you've got a really good connection from the top piece to the next piece to the bottom piece. Everything is piloted in a spigoted fit. So you always get good concentricity from top to bottom. And sometimes that's a real problem in some of the other products people use. The other nice thing, it's got the ability to change your rotor lift. So many times in a pump, you need to be able to lift your pump rotor just enough to get the impeller off the bottom of the case. So that's very easy to do with this product. And then the other thing I'll show you at the very end, it's really neat, is that you're able to do some very fine tuning on the alignment, which is a really critical piece of the puzzle for a lot of people, because they don't have a good way to get their equipment into that final great alignment position. So some things to think about from in terms of just the pump engineering end of it. If you're designing a pump or designing pump components from the start, there's some advantage to using this product, not just in a retrofit, but at using it from the start of the design process. For one reason, you could use on your pump shaft, now you don't need to use any threads, keys. So it really makes the manufacturing process easier on the pump shaft. So you can just buy pump shaft quality shafting, and that's it. You just cut it off to length, and you've got your finished shaft. The other really nice thing is, if you're not going to be putting any keys in it or threads, you've eliminated all those stress concentrations. And once you eliminate some of those stress concentrations, you can actually use a smaller shaft. Now, it may not be possible in every application, but just think, if you can go from a 1 3/4 inch shaft down to a 1 1/2 inch shaft, you've just saved a lot of money. You've also allowed yourself to now use a smaller seal, which is more beneficial. So it's a really nice set of features that kind of domino effect with each other. The other really great thing is that when you start to eliminate some of those features, especially like a threaded section on the top of a pump shaft, you can start to make that pump shaft get a little shorter, which makes the motor on the pedestal sit a little bit lower. And the more you do that, the more you eliminate some of those read critical frequency issues that you might have. Sometimes I know pump engineers are fighting against that all the time. They have this motor sitting up on a pedestal, and it's trying to wobble at certain frequencies. If we can make that whole stack shorter, all of a sudden some of those frequency issues go away. So it's a ripple effect. If you're able to make those changes on your pump shaft, this can be a big help. So we look at what people are using right now. There's a couple very common things they're using. Clamshells tend to be pretty common, and if you see a couple of those pictures, you've got sometimes they're clamshells that are machined out with specific shaft sizes on each end with nut spacing for some nuts or some other little sleeves in the middle. Sometimes you have other more generic ones. And then the other kind that you see quite a bit is a rigid coupling that has an adjusting nut in it. And you can see the picture on the right. That has, you can see it's a rigid sleeve, and then there's a nut in the middle that's used to make, as you turn the nut, it adjusts your pump up to get that lift. So that's the two examples I'm going to be talking about, just in terms of how we replace those and how that helps you. So in the case of the normal rigid coupling, usually you have to have some kind of slip fit. It has to be able to slide onto the shaft and then slip up above on the motor shaft high enough to get a split ring key in. And that's the little black cross-section piece. So the problem there is you have to have clearance. You don't have a good fit on the shaft. So what ends up happening sometimes is, because of the way that hub sits on the key, on those split keys, your hub doesn't necessarily sit straight. Or it may sit straight, but you also have that gap that can be a spot to generate vibration. You don't have a solid fit with the motor shaft. Now, when you switch to the vertical clamp coupling, now that all goes away, because you have interference on the shaft. You can still slip it on loose, but then it clamps in place, and now you've eliminated any of that wiggle room that you might have had before. When you go down and look at the pump shaft, this is a typical pump shaft might have a thread at the top of it, and that's where that adjusting nut sometimes comes into play. You have the pump hub itself is also loose. It's loose on the shaft, and it's only carrying torque via a keyway. So you have the same problem where you have a pump shaft and a pump hub that really aren't connected rigidly. So there's room for wiggle and vibration. And usually the only thing that's locating anything to the pump shaft is that adjusting nut, using the threads on the pump shaft. And I think if you ask a lot of people in the pump industry, are those pump threads cut perfectly? Usually not. They do a good job holding the load, but they're not necessarily machined in a perfect way that it really centers the coupling well. So you have that little bit of air that you're throwing into your system all the time. So what's great on our product, again, we slip onto the pump hub, but then it just clamps in place. And now you have a nice tight fit. And if the threads are there, you can see in this diagram, we work right around the threads. And if we need to, sometimes we can put a threaded piece on just to fill up space if that's needed. Now, when you look at the other kind of coupling, a clamshell, clamshells are usually split in half. You can see here's like a top half and a bottom half, and they're pulled together with some bolts. And the issue is when you pull them together, it clamps in one direction, but it doesn't clamp the whole way around. So you really leave yourself, depending how that fit is, you leave yourself with a little bit of a gap somewhere. And that can be problematic. And what happens is, as if anyone's used these clamshells before, they'll tell you the first time you use it, it fits pretty well. Once you take it out of service and put it back in the second time and the third time, they tend to start getting warped. Things start to twist a little bit. They don't have the perfect curvature that they once did, and the fit gets worse and worse. So at that point, it's just dumb luck at that point how your motor and pump shaft are going to align themselves. So what happens is when we switch to our product, now you have a great fit, 360 degrees around the shaft. Everything is tight. You have no wiggle room. There's no direction that's uncovered. So it's a much better solution. So next, I wanted to show you, how does this work? When you go install this coupling, how does it look? What happens? So the typical, and there are different ways to do it. We have some customers that like to do it a different way or a different order of operations, and that's fine. Whatever works for you is great. Here's what we recommend though. First, you start by putting the pump hub in place. So you would drop it into place, and then you can tighten it in whatever spot makes the most sense. Then you take the motor hub and you would slip it onto the motor shaft and slide it up and keep it loose. So you're just holding it there Essentially, you can hold it with your hand, slide it up, hold it in place until you slip the center spacer in between. So now you put that center spacer, now you have a little bit of a stack. Everything is sitting on the pump hub. It's at the bottom, then you have this spacer sitting there, and then the motor hub is resting on top loose. At that point, you decide how much lift you want on your pump. So maybe it's only 10 thousandths, maybe it's a 1/4 inch, maybe it's somewhere in between. You can put a shim, use a feeler gauge or any other kind of shim between the motor hub and the spacer. So now you have created that gap that you want to lift your pump. Once you've done that, now you can go ahead, reach in and tighten the motor hub in place. So you go through the tightening process. And once you have that tightening process done, the motor hub is fixed, the pump hub is fixed, and now you're going to do the final step of putting in the flange bolts. And as you do that, you'll start to just see those two flanges come together. And what you're doing is lifting the pump, you're lifting the coupling and the pump. So now the whole pump rotor has lifted itself into the final running position that you wanted it. And if you ever need to adjust it, it's no big deal. You loosen the motor hub, move it to a different spot. Maybe you want to shim it differently. And now you're ready to go. So at this point, we've got the couplings in place, ready to run. But this is where it really gets good. This is where you want to look at how can I align this piece of equipment perfectly using the coupling. So what we recommend is, again, all the components we have they're all piloted, so they have great concentricity. They're balanced like that. So you have a nice product that you have in place. What this final step will do is give you some very, very minor corrections to make sure everything top to bottom is really perfectly aligned. It takes any of the wiggle room or slop out of the system. You know, in reality, you still need to align your motor to your pump. That should be done before you put the coupling in. And I think most people still do that. So we don't want anyone to think that just by using this coupling, you can eliminate your normal alignment process. You can, but this will help get it really perfect at the end. So what happens is this diagram is very exaggerated, obviously, but this is in reality, you might have a situation like this where there's a little bit of pitch in the motor, maybe in the pump. There's a little bit of a misalignment. And when you look at the run out on the pump shaft, hopefully you can get an indicator somewhere down near the seal. You might see 5 thousandths, 10 thousandths, 15 thousandths even. And with normal couplings that you might use now, people live with that. They have pretty high runouts on the pump shaft, and there just isn't a good way to get it out. They might try adjusting things differently, but in reality, you're fighting it's really just a bit of luck to see if you get the run out of your system. So in this case, though, you can take a good measurement, have that indicator on, and then you start tweaking those loading screws a little bit. So as you say, you start with the pump shaft or the pump hub, you can just start to tighten each of those, just maybe a little bit on one side, and you'll immediately see which way things move on that indicator. You can do the same thing on the motor side, go in and just make some very fine adjustments on one side or the other, and you'll see the pattern. Maybe if you tighten the ones on the left side, you'll get a certain movement. If you tighten the ones on the right, you'll get a different movement. And once you see that, it becomes very easy to start dialing in, go back and forth a couple times, and now pretty soon you'll end up with a perfect run out. And this has been the case with a lot of our customers. They've said, wow, this is amazing. We used to spend a whole shift trying to align top to bottom once we have a clamshell in. Now we can do it in 5 minutes. Put the coupling in, just spin it, make a couple adjustments, keep looking at the indicator, and when we've got it, it's great, we're done. So it really saves a lot of time in the field, especially, picture yourself in an outage. You want to get this pump back up and running as fast as you can. This helps you do that and have, not only is it back in service, but it's back in service better than it was before, because now the run out is great. Your seals are in a great position now, having very little run out going through them. So I'll just point out our website, couplingcorp.com, is a good resource. Obviously, there's a lot of information there about all kinds of products that we make. But I'll point out if you have an application and you have a vertical pump and you say, hey, I'd like to get a drawing or get a quote on one of these vertical clamp couplings or a line shaft coupling. This hopefully you can see that just a fill in the blank field. You can give us some of those dimensions. If you don't have all of them, that's fine. We can work with you to try to figure out what the missing pieces are. This will be enough information. We can give you, we have some standard models set up that we can use to get you a drawing and a quote very, very quickly. So hopefully that will help people in the field. You know, if they not sure what they need, they can go right to this page and boom, fill in those details and you're off to the races. We'll help you with that. While you're on the website too, you can take a look. We have a blog site. We try to put every month or two, try to put in information that's helpful in different applications, different industries, for different types of rotating equipment. Hopefully you might find something there that's also useful for you. So that's all I have.
I loved it, Jim. Thank you so much. And yes, definitely, Coupling Corp's website is a great resource to be able to learn different applications, see the different installs that they've done, and again, just learn more about how their products can help you. I do have a few questions for you, Jim.
Sure.
So, I mean, overall, I think it's like, it just is a no-brainer. I feel like, of course, it's going to save you time and save you money, but then also like it's protecting your equipment, which is obviously a really big deal. And you
Right.
want to do. So whenever you're using this for a pump, does the pump need to be modified to use this product?
No, it's a great question. We get that a lot. No, you don't need to modify anything, motor or pump. So this is, you know, we designed the coupling to slip right onto the shaft as it is. As I think I mentioned a little bit, if you have a thread, there's many different kinds of threads and people have different shaped shafts, but typically there's always a way to work around the existing thread that's there or the key. Usually if there is a keyway, we'll end up putting a half key or recommending that you put a half key in that keyway just to fill the space, fill in the weight for balance purposes. So no, you never need to retrofit anything. Usually you can take your old coupling out of service, put this new one right in and not worry about it.
I like it. Easy. Is there a limit to the amount of lift, like the pump lift that you were talking about that you can do with this product?
Yeah, good question. There's not necessarily a limit. So as I mentioned, you can put in a very small shim. You can have a very small lift, a couple thousandths. You could have a 1/4 inch, half inch. The only thing at some point, if the bolts aren't long enough to be able to lift that much, we could put longer bolts in that would give you a bigger lifting space. So that's the only adjustment we could make if you had a huge amount of lift.
Okay. Is it possible for this to come loose, like especially with the vibration and all of that?
No, it's a great question. We get that all the time. We've gotten that question for 30 years now with our Anderson clamp hub product. Everyone wonders, well, it's just holding with friction. Will it come loose? And the answer is no. If you install things properly, it really holds forever. The way the loading screws line up, there's a whole set of loading screws, and even if one loading screw backed out, the rest of them are all being held in compression with a load pushing back on them, so they can't back out. So we've never had a problem like that. Things have worked really well in the field. We've been very impressed with how well things have held up over time.
That's definitely good to know. And I feel like I would be asking those same questions too. You never know. You just better to be safe than sorry.
Yep, never know.
Will this product help pump seals and bearings?
Yeah, we've had a lot of good results with people. Before they've switched to our coupling, they've had issues with premature seal wear, premature bearing wear. They're constantly changing seals in a much shorter time than they would like. And this has helped in a lot of cases. Now they can extend that runtime dramatically because their seals don't wear out, just because you've eliminated a lot of the run out and the vibration you might have had before. Mm-hmm. So it doesn't mean there's still, obviously seals will still wear out at some point, but at least you can help it with having good alignment, having less run out, having less vibration. That really helps bearings and seals, and that's anyone that owns that equipment should certainly appreciate that fact that hey, let's get more runtime. Let's get, let's get less repair time and more runtime.
Mhm. Yeah, absolutely. And I think that when you were talking about the alignment and like that fine tuning, I do think that it's just it's so important. And it seems like such a little thing, but at least in
Yep,
if
it can
you're in
make
this
it can make a big
industry, like,
difference. Yep.
um, what materials can this be made out of?
Good question. So the couplings that are, if you're looking at a line clamp coupling, those are typically going to be a stainless, a Monel, Inconel, something that's made for underwater, super duplex, nitronics. Those are some of the materials that get used in the underwater applications. On the vertical clamp coupling, that's usually out of the water or out of the fluid. Those are typically an alloy steel, but we have some customers that maybe just on their location, or maybe the product they're pumping has more caustic nature. They can all be stainless. So we have some customers that like to have all stainless, and
Mhm.
that's fine. All the hardware, the components are all stainless. So there is a variety there, but if you have specific needs, obviously, if a customer lets us know, we can usually work around pretty much most of the normal materials.
Yeah. Now, with this product specifically, what is the typical lead time that people are seeing?
Good question. What we tried to do with this product is try to make a nice standardized size range. So, for instance, if you have any normal NEMA size motor, any of the typical pump shaft sizes, we try to stock those hubs in those sizes, and then we'll also try to stock some spacer lengths in between that might be standard. But usually, what happens is we try to arrange our manufacturing and our production so that if you have an outage, you can let us know when maybe you bring your pump out of service this week and you can get some measurements, find out what your old coupling is, give us those measurements. Hopefully within a couple weeks, we can get you the new coupling into your hands so you can install it before you go back out of outage. That's always our goal, to try to make the timing work out to fit your outage profile.
Yeah, and that's
Sometimes it's
still
not
pretty
possible if
quick.
there's sometimes it doesn't work out perfectly, but that's generally what we try to do. We try to stock those certain products that make sense to really help speed things along.
Yeah, because the lead time I know is important for people, because unfortunately the nature of it is that a lot of the times it breaks and you don't have a backup. And so
Right.
it's
You might
just
not
like,
have
oh
control
crap, we
over when
needed
you
it yesterday.
exactly. And we try our best to work with customers who, especially in those situations where they have an unexpected outage, they're down. We do our best to really go to great lengths to try to get them something back. They can get equipment back together and running again. That's always that makes us feel good when we get someone out of a pinch like that.
Yeah, absolutely. Now, how can people buy this product?
So they can contact us directly. Depending on your location, we might have distributors in that location. I know sometimes with new customers, if you come to us and maybe you're not set up with us as a supplier, and you need it in something done right away, we can work through one of your local distributors, no problem. So the first step is just reach out to us. You can call us or go through our website, and we'll figure out from there how to get that coupling into your hands.
Awesome. And the last thing I wanted to mention is that you're going to be at TPS next week. And, what can people expect to see at your booth and, learn about you whenever they're there?
Yeah, we'll have a lot of fun stuff to see. We have one thing people always love is we have a rotating equipment little table set up. So we have a coupling running with high misalignment on it. So it's neat to see that. We've got all of our products. So one thing's fun for people to do is to play, actually get your hands on a clamp hub or one of our vertical clamp products, and you can actually test it yourself. You can tighten it up on a shaft, see if you can pull the shaft out with your hands. So that's people. It's fun to be able to put your hands on something and try it, and usually it makes more sense then.
Yes.
So yeah, we look
And
forward to seeing everyone.
absolutely. And, I won't be there, but our team will be. And so we'll get to be able to stop by and see it. And if you want to take the challenge to be able to check it out yourself, definitely stop by their booth. And
That'd be
Jim,
great.
Thank you so much for your time and your expertise. I'm very much looking forward to the next thing I get to learn from you.
Hey, thanks for having me.